Good day everyone. So my name is Siti Mura Fasiha and my two other group members are Nur Sharna binti Fadul and Muhammad Zaim bin Sibili. So we are from group 7 demonstrating chapter 10 which is user registration and login module. So today I will be demonstrating the user registration and login module for our mobile application implemented natively in Android Studio using Kotlin. As you can see on the screen, the application defaults to the login state, and to achieve a clean user experience, we didn't create two separate activities, but instead we develop a single dynamic login activity that toggles its state programmatically using Android view binding. This one. Now let's walk through the entire life cycle, starting with registering a new user. Okay, now when I click the don't have an account sign up button, look at how the interface shifts. In the background, our toggle mode set on click listeners triggers. It changes the header text to create account, it hides the login button, and dynamically changes the visibility of the confirm password field and password strength indicator from view.gone to view.visible. This approach keeps our layout resource efficient and transition smooth. Now, let's look at the key feature, real-time validation. Well, let's say we want to create an account like this, and then as I begin typing a password, notice the strength text changing, like this one and this one. We attach a text watcher to our password input field via a text change listener. So every time the text changes, it calls our custom get password strength function, this one, this function. This evaluates for criteria using Kotlin expressive functional feature. First, the minimum length of 8, it gives 1 score, and then the presence of digit 6, which give another score, and also uppercase letter and any special symbols. The score maps to a color state using when expression. Here, red is for weak password, orange is for medium strength, and green is for strong password. So if I try to sign up with a weak password, the system prevents it entirely using an early written constraint prompting a toast notification. So for example, I use ABC, which is the weak password here, then again, so as you can see, it prompts the toast password is too weak, which is from, yeah, see, if the username is not empty and already confirmed password is also not empty, password is not empty, but the score is less than 2, then the toast will pop up this password is too weak here. Then it will return on to the set on click listener, which is to insert a new password again. We want to executing a successful registration. Let's create a valid account now. I'll input username and a strong matching password. For example, we use an uppercase letter, ABC, plus a number, and then a character, a special character. Example that. Sorry. ABC 1, 2, 3, 4. This one. And we type the password for this one. And then when I click the sign up button, the backend logic performs empty field checking and confirms that both password string match perfectly. And then upon success, a task confirms the registration, the input fields clear automatically, and the UI dynamically reboots back to the login state, as you can see here. We are back on the login screen. Let's test our boundary conditions and security check. If a user attempts to log in with empty fields, our validation catches it immediately, alerting them to fill in the data. For example, this one, we let them empty and then we just click the login button. So it shows the fill in. Please fill in all fields. Toss. And also, if I type an incorrect or unregistered credential, the app queries shared preference using the username. For example, ABCD. Now, it shows the invalid credentials or account doesn't exist because the return value is null or doesn't match. Also, it clears the input fields to allow a fresh attempts again. Finally, let's enter the correct credential which we registered moments ago, like here. ABC, this one. And we log in, and the login is, when I click login, the app successfully retrieves the corresponding password string. The conditional statement confirms a match, triggers a login successful toss, like this one, and initialize an intent. This one. This intent passes the authenticated username as an extra data payload username to the main activity before calling finish to pop the login activity off the backstack, ensuring security so that pressing the device back button won't accidentally return an unauthenticated user to the login screen. So that's all for login and user registration. After successfully log in to the application, you can see the welcome and the username from this function on the first page. And then on the second fragment, which is the FYP OBE. So this is the real OBE system, UMS FYP. So you can log in from here. For example, my so it functions well. It's functioning as usual. Yeah. And then we can also log out again. So this is for the second fragment, which is the OBE, and we just set the link, load the URL here. And for the third fragment, we have the we just simply have the user profile here. And finally, on the setting fragment, we can log out from the application. Simply clicks the logout button here, and it returns to the login page again. And here's what's in the main activity. Basically, what's in the main activity is to support all the functions and binding all the fragments inside. So that's all from me. Thank you.
So this is our database site. We have a database called Mobile App DB and a table, users table, with 3 columns: user ID as the primary key, username and password, and both are in varchar, and the length is 50. And as you can see, there are already a few users in here, and these were added earlier. And by the end of this demo, you will see a new user appear here after you register from the Android app later on. So this is our Visual Studio Code where we build our API, and it is an ASP.NET Core Web API project written in C#. So the first important file is the app settings.json, because this is where we configure the connection to our SQL server, and as you can see the connection strings here, we are telling the API to connect our local SQL server. And then the server name is my laptops, and then the database is Mobile App DB, and we are using Windows Trusted Authentication, so no username or password is needed for the DB connection itself. And then let's look at our user model. So this is the C# class that represents our users table. So this table annotations tells the entity framework core to map this class to the exact users table in our SQL server, and the properties here match our database columns. And then we have our application DB context, where this is the bridge between our C# code and the actual database. And this one line is what gives us the ability to query and write to the users table using the C# code. And all the SQL behind the scenes were handled by the entity framework itself. And then the most important part is the user's controller. This is what the Android app actually calls when a user registers. So when the Android app sends a post request to /API/users with a JSON body containing the username and password, so this method will run, and it takes that data and then added that one to the users table through entity framework, and then it will save it. So if the username is already taken, it catches the database exception and then returns a conflict response instead. So this is our Android side, and we are using a library called WebTraffic2 to make HTTP requests from the app. So let me show you how the sign up button click handler is set up. So here we're building a WebTraffic instance that will pointed at our API space URL, and the URL here is my laptop's IP and port, and then the conversion from Kotlin object into JSON will be handled by JSON converter automatically, meaning it will convert the from Kotlin object into JSON form. So back in login activity, when the user taps sign up, we will grab the username and password fields, and then create a user object and call create user to our API service. So the enqueue method will send this asynchronously, so the app doesn't freeze while waiting for the server, and if the response comes back successful, we will show a task message to the user, which is sign up successfully. And one important thing, in Android manifest.xml, we need two permissions for this work, which is the first one is internet permission, because obviously the app needs to make network calls, and then the second one is the uses clear text traffic flag, because our API it uses HTTP, not HTTPS. So since everything is set up, let's look at the functionality. So this is our login screen. To switch to registration mode, we will tap the don't have an account sign up button, and then for now I will use demo user as the username, and then for the password I will use demo at 1234, and also type the confirm password demo at 1234, and then tap the sign up button, wait for the toast message. So the sign up successful. That means that our Android app sent a post request to the API, and then the API received the request, and then entity framework routed to the database, and we got a success response back. So let's switch to our SSMS. Let's run this query and refresh, and look, we have our demo user is now in the database. So that's it. Thank you.